As a quick follow-on to my last video, I want to show how integrating both the processing system and an HDL module can easily be broken and cause a lot of confusion. So I'm going to go ahead and just delete all of this so I can start over fresh. All right, so we have a fresh blank block diagram, and we can go ahead and add our Zynq processing system. And because a lot of people starting out aren't going to be using the tickle script, I'm going to go ahead and show how most people end up doing this and how this can be a common mistake. So you end up with this processing system, and then do the same thing. You drag in your blinky, and you say, all right, great, I have an F clock coming from the processing system, or even you can run connection automation and do that, and bring that in and connect it up to the clock, make your LED external, do the same process of renaming that, opening up our constraints file, and now we don't need the clock, and we do still need the LED. So that's all set there. You can go ahead and regenerate this, and you say validate, and it'll give you this warning saying that the AXI GPIO clock is not connected. So most people would either then connect this up to the clock, which would work, or since we don't need the GPIO, we can go ahead and just get rid of that. And then while we're here, we may as well fix this issue as well. Now validation is successful. We can go ahead and update our wrapper. Everything's looking good. And then we can take this and run through our full synthesis implementation and bitstream generation. Okay, bitstream generated successfully. And so that all looks good. We'll open our implemented design. We'll see our processing system. We'll see our counter logic over here. Everything looks fine. We'll open our hardware manager, open target, auto connect, and go ahead and say program device, because we think that we want to double check that we did everything correctly and that we didn't break our blinky module connecting it up to the processing system. And if you do that and you program it, the done LED will turn on, but there will be no blinking light. And so if you go back to the IP integrator, you'll see that this looks basically the same as what I did in the last video. The only difference is that I'm using the F clock from the processing system instead of the external F clock. And so often for first-time users of the processing system, they'll think that something is dramatically wrong with the processing system, or they don't understand something. And what's actually happening is that this processing system doesn't get turned on and initialized using the hardware manager. And so all that's happening is that the processing system, as much as it looks like it's automatically connected and part of this architecture, and that we can just generate the bitstream and put it into the FPGA and let it all run automatically, that's not how the processing system works. If we want to get a clock from the processing system, we have to create a project for it in Vitis. And so I'm not going to run through that whole process again. You can go back to my last video and take a look at that. It's the exact same process if you want to test this out. But if you do that, then you'll end up with a blinking LED, and it'll run exactly the same as that step of the process of my last video. And so that can be a somewhat tedious process of going through the whole Vitis setup every time you want to test a simple HDL. And so if you're doing an initial testing of integrating the processing system and a piece of HDL code, I'll usually not do this and do what I did in the first video, which is why I did it that way, is make this external and connect it up to the clock on the circuit board using the constraint files. And if you do it that way, then if you go through that whole process, just like I showed you in the last video, then the entire blinky HDL is completely disassociated from the processing system. This clock and this LED and the HDL are a completely self-contained little piece of hardware inside of the FPGA fabric, only taking one external input clock from the circuit board itself that's external to the Zynq chip, and then sending one external output onto the LED. And so this lives totally independent of the processing system, and you can test any sort of HDL you want without having to implement the processing system. I know that this is a common problem because I've actually done this twice and forgotten about it both times. It's a relatively simple Google search away. This is a common issue that people run into and have asked a lot, but hopefully this will save you a little bit of debugging time trying to figure out why your processing system isn't providing you a clock.